Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework for lesson 6.1.1. First, we're going to start off with our methods and meanings for inequality symbols. So we've learned these in the past, but it's always a good idea to refresh our memory, and I would highly recommend that you take the time to copy down each one of these symbols and the words that are associated with their meaning. Now, there is the shortcut that I'm sure everybody has been taught at some point where we say that the alligator eats the bigger lunch. And I'm going to straight up tell you, Oro teachers, math teachers in high school and college don't like that. They think that's very elementary. However, it is also very effective to understand which direction these symbols need to go within our statement. For instance, if the alligator always eats the bigger lunch, then 7 must be the bigger lunch, right? So that means that 3 is less than 7. So this is the appropriate symbol to use if you need to say is less than. The difference between the is less than and is less than or equal to is like right here, 14 is either less than 14 or it's equal to 14. It's one of the two. It can be less than or equal to, so that would be a correct statement. Same thing applies here with the less than symbol. This is more negative than this number. -7 is more negative than -3, which means that it is less than -3. And in this situation, when the number on the left is greater than the number on the right, we would read it from left to right. 19 is greater than or equal to 14. Okay, so we read the statement from left to right using this terminology. But if you're not sure which phrasing to use, just remember the alligator eating the bigger lunch, and it's eating this side, so that guy has to be greater. And the fact that there's a line underneath it means that equal to is also an option, just like the equal to was an option when you put the line under the less than symbol. And just keep in mind, when we start solving problems, this will become a lot more relevant as to why we choose to have some of them be less than and others could be less than or equal to. When we get into actual word problems that describe the situation, those differences will be made clear. All right, so write the expression shown on each expression map and then simplify them by making zeros or combining like terms. So here, we always want to start off by writing what we've got. We had an x, a negative x, a positive one, and 3 negative ones. When you cancel out the 0 pairs, we end up with just 2 negatives, right? Because x and negative x are opposites of each other. They cancel each other out regardless of the value for x. And then here you've got integer operations. 1 plus -3 is -2, right? Because when you're adding two numbers with different signs, you take whatever sign of the greater number, and then you do a subtraction. So 3 minus 1 is 2, and you had more negatives than positives, so your answer will be -2. Here you got 2 x squareds, you got 4 x's, you got a negative x, 2 1s, and 3 negative ones all being added together. Well, the x squareds just combine to make 2 x squareds, right? There's no 0 pairs happening there. But you do have a 0 pair that happens with 1 negative x and 1 positive x. So 4 minus 1 is 3, so you end up with 3 x's. And then you have more negatives than positives, so once you clear out the 0 pairs, you're going to be left over with a negative. 3 minus 2 is 1, and that is -1. So we'll write this as either 2x squared plus 3x minus 1 or 2x squared plus 3x plus a -1. Really, you can do it either way. All right, which expressions are equivalent to the perimeter of the shape? Remember, the perimeter is the distance around. So this is an x, this is a 1, this is an x, this is a 1, this is a 1, this is an x, this is a 1, and this is an x. So how many total x's are there? 4 of them. How many total 1s are there? 4 of them. So this would be the obvious choice, but you know, you could have said x plus x plus x plus x, 1 plus 1 plus 1 plus 1. You could have done that, or you got 2 x's here plus 2 plus another 2 x's plus another 2. So A, C, and D are all different ways of showing this expression, but C is in fully simplified form. All right, fraction operations. How do we add and subtract fractions? Well, first you need a common denominator. Once you have a common denominator, then you have to keep track of the numerators, and you have to keep track of the signs of the numerators and what operation is taking place. For instance, for A, if we start with negative 3/4 minus 2/5, I would recommend that you change that using KFC to plus a negative 2/5. Now we know that when we add these two fractions together, we are going to add the numerators and keep the signs because the signs are the same. So this is going to end up definitely being a negative answer. Now we need to get a common denominator. And our common denominator is going to be 20. So you multiply this times a giant 1 of 5 over 5, this times a giant 1 of 4 over 4. Right? When you multiply 1 times anything, you do not change its value. We are going to manipulate the numbers in the numerator and denominator so we can get two fractions with the same denominator. So this becomes negative 15 over 20. This becomes negative 8 over 20. And now when you add those together, you get negative 15 plus negative 8 is negative 23, and you keep your denominator. That's your final answer. If you choose to rewrite it as a mixed number, you may. How many 20s fit into 23? One of them with a remainder of 3, so it's negative 1 and 3/20. So every single one of these problems, you want to take the exact same approach. If it's mixed numbers, I would recommend you change them to improper fractions. I take this one and make this 5 over 3 plus negative 2 over 5. Now get a common denominator, and now you'll do a subtraction because you've got two different signs, and your ending answer ends up being 19 over 15 or 1 and 4/15. I'm not going to work through these. If you got these wrong or you don't understand how this works, you need to take the initiative and ask me to help you with these. Okay? I'm not going to spend 20 minutes working over problems that everybody knows how to do. The only way I know whether you understand this fully and feel comfortable is if you communicate that with me. Okay? So I'm moving on, but send me an email or jump on to a meet and ask me to work out some of these problems if you need me to. All right, Desmond is rolling a standard 6-sided number cube, otherwise known as a die or dice. He plans to roll 72 times. About how many times would you expect Desmond to roll a 4? Okay, so back to the basic ideas of what probability means. If there's one 4 on a number cube, that's 1 out of the 6 sides is a 4, it really means that if you rolled the dice 6 times, you would expect the 4 to come up 1 time out of every 6 times that you roll it. So every 6 times you roll it, you get a 4. So if you roll it 12 times, you'd get 2 of them. If you roll it 3 times, you get, or 18 times, you'd get 3 of them, and so on and so forth. So that's where the proportional reasoning comes into play. If you roll this dice 72 times, you expect 1 out of every 6 times for it to be a 4. So we'll use proportional reasoning. Think of your giant 1. What do you multiply times 6 to give you 72? That number is 12. So 1 times 12 is 12. So we expect it to be 12 times. And if you're not quite sure, you can always do the cross multiplication. 6 times x is 6x. 1 times 72 is 72. And when you take 72 divided by 6, that's going to give you your value for x now, which is 12. About how many times would you expect to roll an even number? Well, what are all the even numbers? You got 1, 2, 3, 4, 5, and 6. So 2, 4, and 6. That means you got 3 even numbers. So it means half of them are even, right? So your probability of getting an even number on a die is 1/2. So half of the time we would expect to get evens. So half of 72 is 36. Absolutely. So you can solve it somewhat logically, or you can set up the ratios and do your cross multiplication, and you will get 36 for your answer. Okay, so Desmond kept track of his results for all 72 rolls. The table at the right shows the results. This is experimental probability. Just because the theoretical probability says a 4 should come up 12 times or an even number should come up 36 times doesn't mean that's exactly how it's going to work. So looks like for these outcomes, what was this? The 1 happened 9 times, the 2 happened 14 times, the 3 happened 11 times, and the 4 happened 8 times, which was less than we expected, right? We expect all of these to happen 12 times, but that's not really how it works with the experiment. So it says, based on his partial results, How many times did he roll a 5 or a 6? Well, if we add up all these, 9 and 14 makes 23, plus 11 is 34, plus 8 is 42. So the rest of them must be 5s and 6s, right? Because those are our only options, 1, 2, 3, 4, 5, and 6. So out of the 72 times rolled, 42 of them happen to be here. The rest of them would be either 5s or 6s. All right, in parts A through C below, you will see pairs of quantities. For each pair of quantities, use the words to write a sentence that describe the relationship. For example, 5 and 8 could be 5 is 3 more than 8. Okay, so you actually could have chosen a few different statements here. So I'm not going to go over every single possible one. You could have shown that there's a multiplication process here, that 3 times 13 is 39, or 13 is 1/3 of 39 if you took 39 and divided it by 3 or multiplied it times 1/3. So you could also had an addition relationship here where 39 is 26 more than 13, right? There's more than one possibility for what you could write. Same thing here. There isn't a multiplicative relationship there, so I just said 25 is 8 more than 17. And here there does appear to be a multiplicative relationship where 38 is 19 times 2, or 19 is half of 38. So, answers will vary. If you're not sure if yours is correct, contact me and I'll be happy to answer for you. All right, we are going to start working with inequality symbols. So it says copy each part below on your paper, then use the number line to help you fill in less than or greater than on the blank line. Okay, so how do we compare -5 and -2? Well, -5 is located right there, and -2 is located right there. Since -5 is farther to the left on the number line, we would say -5 is less than -2. 8 is here, and -1 is right there. So 8 is farther to the right on the number line, so 8 would be greater than -1. And then -5 is a negative number, which would be less than 0, and -5 is actually, or I'm sorry, -15 is actually farther to the left than -14. So -15 is less than -14. And that is it for our homework. So let's go ahead and move on to the next activity. I believe, I guess we're checking homework, so this is 2. We've got a lesson to do next. All right, let's move on. Bye.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.